Welcome to Easy Math TV. Here's another video in our statistics series on StatCrunch tutorials, and we're focusing on inference on a single sample. And the previous two videos to this, we did some testing for normality. In other words, we wanted to know if our sample came from a normal population. And then our second video was kind of an introduction to confidence intervals on a proportion. Today, we're going to talk about confidence intervals of a mean. And when it comes to that, we have some choices to make. So I want to sort of go over with you the differences between the two types of um, testing that we use, whether it's confidence intervals or a hypothesis test. And it comes down to whether or not we're going to be using the student T distribution. So that's a new distribution that I'm going to introduce you to versus the Z. So you're quite familiar with Z scores and the Z distribution, but new is something called the student T distribution. So I want to illustrate this by just assuming that we have a random sample of size n equals 34. That's all we know right now. And our confidence level is going to be 95%. And the other part that we know is that we are trying to find a confidence interval on a mean, which is given by the Greek letter mu. So that means that we're going to be needing a critical value that's part of our calculation. And the critical value is either going to be denoted by T star or Z star. And just to remind everybody, the role of the critical value is to stretch the confidence interval by an appropriate amount to ensure accuracy of our estimate. In other words, if you recall, if our confidence level is 95%, then the probability of a type 1 error is 5%, which means the probability that the true mean is outside of our interval is going to be 5%. And we want to basically guarantee that. And the only way to guarantee that is to stretch our confidence interval by an appropriate amount. And that's what the role of the T star or the Z star is. So the larger critical values mean that our wider estimate interval, right? So if our T star or Z star is greater than 2, for example, so if it's like 2.5, that's really going to stretch our interval out and maybe make it a little bit less practical and less precise. So an interval that is too wide actually becomes impractical. There's not much use for an interval that's too wide. If you're trying to find your lost cat and somebody comes to you and says, "Well, it's within this 10 square mile area and it's a wooded area." That's not really narrowing things down by much. It means you've got a huge territory to look for your lost cat. So we want our intervals to be a little more manageable. So you want your margin of error to be um, controlled by your sample size. Okay. Um, Anyway, the purpose of this video is really just to show you for this situation here where we have a sample size of n equals 34 and our confidence level is 95%. What would the difference between a t value and a z value be for that? What's the difference between the two critical values? Okay. And I want to use StatCrunch for that purpose. So I've brought it up in this window here. And basically, when you're looking for a critical value, you go to your stat menu and you're just basically looking up. We're just going to use our calculator here. So let's start with the T. So I'm going to go to calculators and go to T. And we're looking for in between. So we want the T calculator in between. And the first thing we notice here is it's asking for something called degrees of freedom, which is DF. So the letters DF stand for degrees of freedom. And that is always going to be your sample size minus 1. So since our sample size was 34, that's going to be a 33. My degrees of freedom is 33. And then just as we did with our proportion, we're going to leave these two numbers blank here. And then I'm going to put my confidence level number on the right-hand side, which is 0.95. And then I'm going to hit compute. So the positive of those two numbers, 2.0345, that's going to be my T star. Okay. So if I pull this back up, T star is equal to 2.0345. Okay. So I'm going to leave that window up here. And then let's also then bring up our calculator Z, which is normal. So you're not going to see a letter Z here. You're just going to see normal. And again, we want in between. And now you might think, oh, I don't know the mean and the standard deviation. Yes, you do, because we're looking for a critical Z value, if you recall. So our critical Z value means that we're actually looking for our standard normal here, which means that our mean is 0 and our standard deviation is 1. So yes, we do know what those numbers are. And I don't know why this is popping up on me, but it's been doing that. Okay, so again, we want to blank out these two squares here, and the one on the right is going to be 0.95 again. And I'm going to hit compute. So look at the difference between these two graphs, and you will see that, I mean, this one, the Z graph is stretched out a little bit more, but the Z value is 1.96. So I'm going to write that in here, Z star equals 1.96. And remember what I said about comparing, like what does this critical value actually do? When the critical value is larger, it's going to make our interval wider. It's going to stretch it out more. So T star is slightly larger than 2, and Z star is underneath 2. It's 1.96, which means that if we can get away with it, we would rather use the Z star or the critical Z rather than the critical T. But as we're going to find out very soon, if we do want to be able to use the critical Z, we have there's more requirements on our data in order to be able to justify using that on a mean. So in the next video, we're going to run through a couple of examples. And in one of them, we have to use the critical T, or we have to use the T distribution. In the other one, we're going to be using the Z distribution. So I just wanted to show you that um, there is a difference between whether or not you're going to use T or whether you're going to use the Z. And a lot of that it depends on what our assumptions are about the data. Okay. And we're going to address that in our next video. So like, subscribe, comment down below if you have any questions. I'm usually monitoring this and I can answer questions. Um, share these videos with other people if you think they might find them useful. And I'll see you in the next video.